True or false, the box on the right, the kinetic energy in here. So particles are moving around like crazy. Kinetic energy is energy due to motion. So is the kinetic energy double in this box as it is in here? So let's give it a number. Let's say kinetic energy here is 100 kilojoules. Is it 200 kilojoules here? Is your kinetic energy doubled from that box to this box?
Okay.
Okay, what do you think? No, it's not doubled. Very good. It is not. Tell me why.
I just remember you talked about this yesterday.
Okay, well, fair enough. Who can help her out? Why is it not doubled? Cody.
Because it spreads out, so the space that it's like covered.
Well, this is 1 liter and that's 1 liter. What if I told you the same volume? I might have drawn them a little different, but let's say the volume is the same. So in other words, the spreading out, it's equal. The distance between particles is equal. Why else? Why is the kinetic energy here not double what's inside this box? Cheyenne?
Because Celsius isn't proportional.
Right. Look in your notes. Look at the graph. Here's your graph. Here's directly proportional. What's this axis right here? Kinetic energy, right? KE. What's this? Temperature in Kelvin. 25 times 2, does it equal 50? Yeah. But guess what? This is 298K. This is 323K. Is that number twice that number? No. You'd have to have 566 or something like that. So this is just reviewing what I said yesterday. Celsius, especially with gases, isn't really helpful. We have to convert it to Kelvin, and that will tell us if the particles are moving twice as fast, 3 times as fast. All right, now I'm being a little bit, I'm not saying that correctly, but kinetic energy is due to motion. So to help you understand, they are definitely moving faster here because they're hotter. Things that are hotter move faster. Okay? If you want to pop a balloon, just heat it up, right? Put some air in a balloon, tie it. It'll just sit around. It might deflate over time, but if you want to pop it and not physically put a hole in it, heat it up. The gas will expand, start to move around very fast. The balloon won't hold it, it'll pop. So the hotter it is, the faster they move, but Kelvin is directly proportional, not Celsius. Okay, moving on. Here's what we're doing in our notes now. What do we got, 15 minutes?
Yeah, like 5.
Close. Okay, particle diagrams. Particle diagrams. All right, that's the title. Here's what you're going to get out of the video. Let's do it this way. Let's write atoms / elements. And you're going to be drawing some pictures of them next to that. Maybe skip a couple lines. Molecules. Skip a couple lines. Compounds. Skip a couple lines. Mixtures. Yeah, the problem is these overlap, these 3. Sort of. It's kind of hard for me to set up a perfect notes here. You'll see when you see the video. All right? But the point of the video is so you can do your homework and learn what particle diagrams are. How do you draw what an atom looks like? How do you draw what an element looks like? How do you draw a molecule? How do you draw a compound? How do you draw mixtures? So we're going to watch the video. I'll stop it, talk a little bit. You'll write down some things. All right? And that's going to be it for today. I doubt we're going to have time to use the whiteboards again. That's all right. We'll do it tomorrow. You know what? Next to molecules, put in parentheses, elements and compounds. Molecules can be both. They can be an element or a compound. You're going to see in the video. So that's kind of your outline. Now you're going to be, again, you're supposed to leave some lines, some spaces, so you can draw some things next to it. All right. So someone hit the lights, please. Here we go.
compounds and mixtures, then this. If you are confused about the difference between elements, compounds, and mixtures, then this is the video to watch. An element is a substance made up of tiny particles called atoms, and they are the most basic form of matter. We can use a simple shaded circle to represent an atom of carbon, let's say. If we used an unshaded circle, that would represent an atom of a different element, such as oxygen. When atoms of elements chemically combine, which we show by having them touch, they form molecules. If the atoms...
Okay, so you should be writing these down. These two are examples of atoms. A black circle is one atom, a white circle is a different atom, and that's it. That's the only symbols we use. Black and white, or shaded, not shaded, right? I mean, it's not always black if you're using a different colored pen. I think you get that. Molecules are when two or more atoms are touching. So when we draw what are called particle diagrams, if you draw these two circles touching, that indicates a chemical reaction, a bond, so they are together chemically. That's called molecule. It can be two of the same color, so two black and two white, or a black and a white, or shaded and unshaded, whatever makes sense to you. Okay, so these are called molecules. Those two are atoms. There's no other options for atoms, either black circle or white. That's it. Atoms are easy. Molecules get a little more confusing. Okay? Again, you're drawing these next to the term in your notes. I'm going to give you a few more molecules. Okay? He's going to get to some of them, but I'm just going to give them to you now. Water looks like Mickey Mouse, so draw that. Water is a molecule, and it's common. That's a common molecule. So draw that next to molecules. Carbon dioxide, a black one with two white ones on either side, right? So this is H2O, and that's CO2. Those are compounds, but they're also molecules. That's why I said earlier things overlap. It's not black and white. It is black and white. Okay. I thought that was funny.
It was.
All right, one person. Tough crowd. All right. So anyways, it isn't, again, I'm just going to say it again, it isn't black and white in terms of all molecules are compounds. All molecules are elements. It actually is confusing with the molecules a little bit. All right, he's going to explain that. But these are two molecules you should get down. Another one, okay, shaded with three white ones around it. That's like ammonia, NH3. Okay, that's another. These are just common molecules you'll see on homework, quizzes, tests, the Regents. There's not a lot that they use. This is kind of it. Either a black and a white, water, CO2, or the NH3 shape. Okay, so again, these are all molecules, more than one touching. Okay, here we go.
Are two of the same kind. We call that a diatomic element. Oxygen is actually found as a diatomic element in nature, like in the air we breathe, and so we write it as O2. Carbon does not exist as a diatomic element in nature, but if it did, you now know how to draw it. Altogether, only 7 out of all of the elements that we know of are naturally diatomic, and they are Maureen, with the word Hunkelbrief. So, what do we call a molecule consisting of 2 or more different elements that are chemically combined? Correct, a compound. And since this
Okay, last year Kiernan was obsessed with that. Does anyone know Kiernan? People know Kiernan. He was, so all year he would constantly say, correct. And I thought that was really funny. If you know Kiernan, it's funny. The molecules, again, can be diatomic. Make sure you write this down in your notes. 2 of the same color are diatomic elements. So where it says molecule, elements, and compounds, you should write these, okay? Which they already should be there. Label them. Those are elements because it's 2 of the same color. Only 7 in the world look like that. Every other element is an atom, just one circle. The 7 diatomics have the 2 of the same color. Any other molecule that is different colors are called compounds. Someone raise their hand and I ignored it.
Wait, what's the one that's crossed out? Why did that happen?
Because if this is the key, if he said black is carbon and white is oxygen, carbon isn't a diatomic, so carbon wouldn't look like that. Carbon would just be that, one black circle. That's carbon. It's not diatomic. Two elements together would be diatomic. And carbon's not a hump of it. That's why it's crossed off. But it's still, you can still draw that. It just, this would represent one of the other diatomics, not carbon, because carbon isn't a diatomic. So the point of today is to understand what is an atom, what is a molecule, what is an element, what is a compound. So if you know what all of those are by the end of the class, it's only a little bit left here, and then apply it to the homework, hopefully you'll start to learn. You're not going to learn it here. You're just going to write it down, try and understand most of it, and apply it to the homework. Okay, moving on. Here we go.
Compound has the ratio of 1 carbon to 1 oxygen. We can give it the formula CO and the name carbon monoxide. Any ideas what formula and name this particle diagram would have? If you guessed CO2 or carbon dioxide, you'd be correct, since there are 2 O's for every carbon atom. And now for the mixtures. You can have a mixture of elements such as carbon and oxygen in the same container but not touching each other, making them physically combined. Or a mixture of compounds such as carbon monoxide and carbon dioxide physically combined in the same container. And finally, there could be a mixture of elements and compounds such as carbon, oxygen, carbon monoxide, carbon dioxide, all in the same container, not touching, physically combined.
The key is not touching. Go ahead, draw those in there in your notes. All 3 of those. Make sure you label what the heck it is. Mixture of elements, mixture of compounds, mixture of elements and compounds. This is what the homework's going to be kind of like. All right, this is what Regents questions are like. They may say